Hello everyone. So now we are going to solve the same problem that we have solved previously, which is the transportation problem. Previously we used the long form, I would call it. Now we are going to use the compact form, in which we define things in for loops. So here is the problem. We have supply and we have demand, and for each supplier we have capacity. So for the first one we have only 400, it cannot supply more than that. And for each demand node we have a specific demand. So for the first one we have 320, and that demand should be fulfilled. It cannot be less than that. And each edge is assigned a value. This value represents the cost. What we're trying to do is to minimize the cost while fulfilling the demand and not exceeding the capacities. So we'll solve this problem using the compact form. First, I will pip install Gurubi Pi, and I will use the version that is greater than 10, as we did previously. The second thing is that not every problem I will need to read the license of my Gurubi Pi. The license is needed only if the problem is huge, in which we have more than 2,000 decision variables and more than 2,000 constraints. For regular problems, using the free version of Gurubi Pi will suffice. So I will import Gurubi Pi as GP. Then from Gurubi Pi, I will import GRB. I will also import another library, which is NumPy, as NP. Now, the first thing I will do is to define my supply. Here I have 3 suppliers, so my supply will be just range of 3. And what range 3 is, it's basically a generator. We can imagine it as a list. There is a technical difference between a list and a generator in Python that is out of scope here, but let me just print it out and see how the generator, how this range works. So it's going to be 0, 1, 2, because we set it as range of 3. It will start from 0 and it will end at 2. And if I do list range 4, it will start at 0 and it will end at 3. Let me delete those 2 cells. And this is the supply. For the demand, we will have range of 4, because we have 4 nodes over here. Then I will build an array in which I will put my costs that I have over here. So from node 1 or 0 to 0 it's going to be 15. From 0 to 1 it's going to be 17. 0 to 2 it is 14, and so on and so forth. So I will do that row by row. So I will call it costs. I will use the NumPy library, and I will build the array. I will input my or open my parentheses and open square brackets, and I will populate the first row. First row is going to be 15, 17, 14, 18. Then I will put a comma, start second row. The second row will be 18, 12, 13, 19. Then comma, and I will start a third row. 13, 15, 16, and 13. So here are my costs. I can also build another array, which will be for the capacities, and np.array. And for the capacities, I have here 400, 750, 380. I can also build another array, which is demands, and here demands differs from demand. This is one variable and this is another one. Here demands tells me about the quantities of the demands. Array, and it's going to be 320, 280, 560, 370. And here we go. We have defined our parameters. Now the next step is to define the model, and I will call it M is GroupiePy.model, and I will give it a name, which is, let's say, network. Here I don't need to define the environment because I'm not using my license. As I said, for small problems, the free version will suffice. So I have defined my model now. After defining the model, I will define my decision variables. So my decision variables, I will give them, I will use this expression for them, x, and I will use model.add vars. Previously we used .add var for one variable at a time. Now we will add all the variables at the same time, or more than one variable at the same time. Once you add more than one variable at the same time, you will use add vars. And here the variables are going to be from the supply that I defined to the demand, and automatically GroupiePy, it will understand these are links. So I'm linking each supply to each demand. So here we have 3 suppliers and we have 3 demand nodes, so we'll have 12 variables, and it will understand that automatically. Supply, demand, from supply to demand, and I will give them a name. I can call them quantity. So I gave them the name of quantity. Now I will set my objective, and my objective is to minimize the cost. So the summation of the multiplication of each quantity with its corresponding edge cost should be minimized, which is this line. It's a long one, but we'll do that in the compact form. So m.set objective open the parentheses, then GroupiePy dot quick sum. This is a built-in function in GroupiePy that does the summation. It works as the summation sign that we use in operations research and mathematical formulation. So GroupiePy.QuickSum x. So we have named these decision variables as x, and the summation of x from the supply I to the demand j multiplied by the corresponding cost. So I have costs, which is here, and the cost is going to be of I and j, same I and j, for all i's, so I in supply, and for all j's, for j in demand. This should be minimized. So I will give it a sense, which is GRB, this one that we called over here, one of the classes of GroupiePy dot minimize. And everything here is case sensitive, so you should print it in the correct form. Now I will run this. So this actually does the summation over all I and all j, multiplying the quantities of the decision variables by their corresponding costs. Now we set our objective. What we will need to do now is to add the constraints. So I will add the first set of constraints. The first set of constraints is for the supply part. So this is for the capacities, they cannot exceed their values. So for the first one, it cannot exceed 400, the second one cannot exceed 750, and the third one cannot exceed 380. So I will add constraints, and because we will add multiple constraints at the same time, we'll use this time constraints. I will add this S, which will indicate that I'm adding multiple constraints. So in this constraints, this set of constraints, I will need to sum over all demands for each supplier. So all demands 1 or 0, 1, 2, 3 for supplier 1 should not exceed 400, and so on for all other demands. So it's going to be RubyPy.QuickSum X, which is the quantities, from supplier I to demand J for all demands, as I said, for J in demand should not exceed the corresponding capacities. I will just take this one. It should not exceed the corresponding capacities for that supplier I. So I'm controlling this. So I is for the supplier, and now it doesn't know what I stands for. I need to give it that sense. So for I in supplier, in supply. So for each supplier, you can imagine it as 3 constraints. I have 3 suppliers. You will go over all demands for that supplier, and you will ensure that it doesn't exceed the corresponding capacity for that supplier. And I can also give it a name. Let's say supply constraint. Okay, we have added the first set of constraints. Now I will add the second set of constraints, which is for the demand. It's exactly the same process, but we will flip the indexes. Constraints, yes, hopefully it's correct. And I will open other parentheses. I will say RubyPy dot QuickSum of the quantities from supplier I to J. Now for all suppliers, for I in supply should not be less than, so it should be either greater or equal to the demands. And I have the demands over here. The demands of J, demand node J or consumer, for J in demand. For J in demand. So this demand is the quantities that are the minimum quantities that I need to fulfill. But this demand is just telling us the demand node. So it can be demand node 0, demand node 1, or 2 or 3. That's the difference between them. So demand here is for the node, demands here is for the quantities. I can then give it a name. I call it demand constraint, and press Shift Enter. Now we are ready to optimize the model. So I will just use m.optimize. Yep, and here is the optimal solution. In next video, I will show you how to print the results in a better way that you will be able to use it in your presentation or in your report. That's it for today.